So our range, got it? We all good with that one? So the question then is, how do we take a quadratic form that's written in standard form and put it into vertex form? And we do this by completing the square, but it needs some additional review. So here's our review. When you guys first learned how to FOIL, we called these special cases. We called these special cases because they follow a pattern. When I FOIL this out, I get x plus 5 times x plus 5. That gives me x squared plus 5x, and 5x give me 10x plus 25. Okay. So do you guys see the pattern? Do you remember the pattern? There was a rule that came along with this. You take the first term and you square it, and then you do 2 times the second term. So it was like if you have a plus b, the quantity squared, the rule is a squared plus 2 times b times x plus b squared. Do you guys remember learning that? Because that's the pattern that it follows. That is the pattern that this is following. So if you think about that, what's going to happen when you take x minus 1 and you square it? Well, we get x minus 1 times x minus 1. But using this rule, square the first term. X times x is x squared. Take the second term, negative 1, and multiply it by 2. What does that give me? Negative 2, and then multiply it by x. Negative 2x. And then take the second term again and square it. What's negative 1 times negative 1? Positive 1. I'm just doing this because I want you guys to easily be able to take the first term of your vertex equation and be able to square it quickly. I don't want you to have to keep writing it out and foiling it. Okay. So again, using that same pattern, if this is written like this, a plus b, the quantity squared, I'm going to take a squared plus 2 times the b term times x plus b squared. So what's this going to become? Well, the first term squared is what? If x is the first term, what is that squared? It's x squared. Then I take 2 times the b term. 2 times is what? Times x. And then I take the b term again and I square it. What's 4 squared? There you go. That's what this becomes. Now, there's nothing wrong with writing out x plus 4 times x plus 4 and using FOIL or even the box method if you want. But I want you to know that this has a pattern to it. There was a trick that you learned early on. Okay? So that's what those 3 trinomials look like when I square them out. All right, number 3. So it says, give each trinomial an exercise 2. What is true about the relationship between B and C? So what's true about the relationship between B and C? So let's look at this first one. X squared plus 10x plus 25. Remember that this is B times X and this is plus C. So what could you say about the relationship between B and C? Okay, what else? I did this 2 ways. They're both what? Yeah, they are. So here's what I wrote. Well, B is the same thing as 2 times the square root of, well, really it's 2x times the square root of C. That's what I did the first time. B is the same thing as 2 times the square root of C. But that means what? What's the undo of multiply? Divide. So that means that B divided by 2 squared equals C. Let's see if that works. Let's see if that relationship works. What is 10? If B is 10, what is 10 divided by 2? 5. And what is 5 squared? Okay, let's check the second one. In our second equation, b was -2. What is -2 divided by 2? It's -1. And what happens to -1 when I square it? Oh my gosh, it works. Let's check the third term. What's 8 divided by 2? And what is 4 when I square it? Oh my gosh, look at that. So this is how you find the value of b for completing the square. That's how you find your value of b for completing the square. Okay? You're going to have to come up with a picture in your brain because we don't have pictures here. So that's how you find that. So I'm going to slide that up a little bit. I got you. Okay. So each of the following trinomials is a perfect square. We're going to write it in factored form. We're just going to write it as factored. So we're going to use that idea of we're going to take the b term and we're going to divide it by 2 and then we're going to square it. So what is 20 divided by 2? It's 10. And 10 squared is what? 100. And that's exactly what c is. Do you see that? So this actually can be written as x plus 10, the quantity squared. Because 10 squared times 10 squared is 100, and 10x plus 10x is 20x. Let's look at our next example. We have to do b divided by 2, and then we have to square it. So b is -6 divided by 2 equals, what is -6 divided by 2? It's -3. And what is -3 squared? It's 9. It's telling you that these are perfect squares. So this is the same thing as x minus 3, the quantity squared. I'm going to pause and I want you guys to do the last one. I want you to do the last one. Rustin, what'd you get? What is 2 divided by 2? What is 1 squared? So isn't that exactly what you have there? So 2 divided by 2 is 1. So it's not x plus 2, the quantity squared, but x plus 1, the quantity squared. Okay. Do you guys see that? Remember that we're trying to find the relationship between these. So if we want to write it as a perfect square, we have to figure out what our b term is. Okay. I'm going to go to the next page. Okay. All right. So we're ready to finally learn the method of completing the square. So this method has many uses, but really we just use it for vertex form. So the quadratic function that we have right now is x squared minus 4x minus 1. And that is shown in the graph right over here. We need to put it into vertex form, okay? So here's what I want you to start with. We have this equation, y equals x squared minus 4x minus 1. The first thing that we're going to do is I just want you to deal with this part. We're going to ignore that minus 1 for a second, okay? We're going to ignore that minus 1. And I want to actually move it to the other side so we can focus on just this grouping. So how do I move this minus 1 to the other side of the equation? I add it. Yeah, add it to both sides, plus 1. So I really have y plus 1 equals x squared minus 4x. Now, b divided by 2, the quantity squared, tells me that if I want to write this as a perfect square, I have -4 divided by 2, which is what? What is -4 divided by 2? It's -2. So I can write this as y plus 1 equals x minus 2, the quantity squared, because this equals -2. However, when I square this, what is actually being added to this side? What is -2 squared? 4. So squaring this actually adds 4 to this side, which means I have to do what? Add 4 to the other side. That's really what's happening when I square that. So I have y, now I don't have plus 1 anymore. I have y plus 5 equals x minus 2, the quantity squared. So I want to put it back in vertex form. So what do I do with this plus 5 now? Subtract it. So y equals x minus 2, the quantity squared, minus 5. Now we just talked about when we did our drawings or like our little activities on the board, we could draw this out and say, what are we missing? We're missing a 4, but we need it to equal a -1. So 4 plus what number is going to give me a -1? Because that's how we did it on the board. 4 plus what number is going to give me a -1? -5. That's why that's -5. Okay. So it says using the method of completing the square, now write the trinomial in the equivalent shifted form. Well, we've already done that. That's already written up there for us. Y equals x minus 2, the quantity squared, minus 5. That's exactly what we did. And now we're going to graph it. We're going to check and see if our graphs match. Well, what's the vertex? 2, -5. My leading coefficient is 1, so 2, -5 over 1, up 1, over 2, up 1, 2, 3, 4. Look at that. Over 1, up 1, over 1, 2, up 1, 2, 3, 4. So you just wrote the equation for that graph. Okay. So completing the square, we're going to write some things in there that I didn't type in, and because it came from eMath instruction, it didn't type in either. So we're going to type some things into that box once everybody is done up there. So this procedure that we just did is an algorithm. In other words, we follow a recipe. And here it is. Okay, so completing the square. For the quadratic that's in the form ax squared plus bx plus c, note that a equals 1. That's the first thing I want you to note, that a equals 1. So what did we do? Well, we took the constant and moved it to the y side of the equation. That was what the first thing that we did. We moved the constant to the y side by using opposite operations. And then we found half of the value of b, meaning we took b and we divided it by 2. That's what we did. And then we squared it, b divided by 2 squared, and that is what we added or subtracted from both sides. That's what it means to balance your equation. You add or subtract the same thing from both sides. And then we just rewrite it as vertex form. Y equals a times the quantity x minus h, quantity squared plus k. So that's what we did. That's the recipe for making this happen. Not moving these back. So I'm going to go into the next page and I'll put this back up in a minute. Okay, I'm going to go to the next page. All right. So we're going to use the method of completing the square to identify the vertex, and we're going to practice it. I think we are practicing it 6 times. Okay. So example 1, the first thing that you want to do is tell me what the value of A is. Well, notice here A equals what? 1. All right. So because A equals 1, my graph is going to smile. That means it's going to open up, which means it's going to have a minimum. True or false? All of those are true. What is the y-intercept? 0, -2. Those are all things that we get from standard form. Now we have to put this into vertex form. So remember, the first thing that we do is we take the constant. The directions say that you take the constant and you have to move it over to the y side. You need to write this down, buddy. So if I take the constant and I move it over to the y side, what does that mean? What does that look like? What am I actually doing? Well, I'm taking this -2 and moving it to the y side. How do I do that? By adding it to both sides. So I have y plus 2 equals x squared plus 6x. Okay. Y plus 2 equals x squared plus 6x. Now I have to do the next step, which says take half of b. What is half of b? It's 3. 6 divided by 2 equals 3. So now I have y plus 2 equals x plus 3, the quantity squared. But when I square 3, Dylan, when I square the 3, what does it turn into? 3 squared is what? So I'm actually adding 9 to this side, which means I have to add 9 to this side. Yeah. We really aren't, like, you're not seeing the add 9 on the right side. It's just done through the squaring. But we do have to add it to the other side. So 2 plus 9 is, plus 11 equals x plus 3, the quantity squared. Last step, I want to move that plus 11 back to the other side. How do I do that? Subtracting. So y equals x plus 3, the quantity squared, minus 11. So my vertex is going to be -3, -11. My vertex is -3, -11. All right, I'm going to go into the next one. Next one, B. Y equals x squared minus 2x plus 11. Well, is this going to open up or down? How do you know? Yeah, A is 1, so it's going to open up, which means it has a minimum. What is my y-intercept? 0, 11. All right, so are you guys okay with us just visually moving that plus 11 to the other side by subtracting it? Like, can we do that without showing that step? So y minus 11 equals x squared minus 2x. What's half of -2? Or b divided by 2 is what? It's -1. So this is really x minus 1, the quantity squared. But when I square that, what is -1 squared? It's 1. So I'm actually adding a secret 1 to this side. You don't see it. But that means I have to add a 1 to the other side. So y minus 10 equals x minus 1, the quantity squared. Last step, add what to both sides? Add that 10 back to the other side. Y equals x minus 1 squared plus 10. So what is my vertex? This is in vertex form. Remember your vertex is h comma k. Say it again. Yeah, it's 1 comma 10. Your vertex is 1 comma 10. So I'm going to have you guys do number 3. Number 3 is a nice integer one again. The last 3 are fractions. So we're going to do those together. Actually, the last 2 are fractions. So I'm going to freeze the screen and let you guys do C. I'm going to have you start C. So A equals 1. Once you get number 3 done, try number 4. So when we square this, that's what that magic 1 comes from. It's negative 11 plus 1. Negative 10. So 1 minus 10 equals x minus 1 times squared. 9 when we have actually other side. So how do I get rid of that minus 10? Also, y equals x minus 1 squared plus 10. Your vertex, that's your h coordinate and your k coordinate. Right? We do this one together. So open up or down. As a minimum. What's the y-intercept? It's 0. So what's it? What did it do with 0? Good job. So let's turn this into standard form. So y equals, there's no constant for me to move over, right? I subtract out 0, I still get 0. So y equals x squared plus 8x. So it's half of 8. So now this becomes x plus 4, the quantity squared. What happens to 4 when I square it? 2. Not take the square root of it, but I squared it. 4 squared is what? 4. Times 4 is what? 16. So really, I'm adding a secret 16 to this side. I'm going to have to add a secret 16 to the other side. So y plus 16 equals x plus 4 the 20 squared. Now move that 16 back over to the other side. So y equals x plus 4 20 squared minus 16. So you tell me what your vertex is. So everybody look at number 3. Yeah. Number 3 is posted. Number 4, I'm just going to write out what what it is really fast. Number 4 is going to be y equals x plus 4 quantity squared minus 16. So your vertex is -4, -16. What do you got, Quali? We need to do the last two together because they have fractions. Okay, so you have to take half of this. What's half? This is 10x. So this is right. But what's half of 10? 5. So this becomes x minus 5 squared. So what happens when you square 12? When you square 5? So that means you're adding a secret 25 to both sides. Oh, right? You don't see it here, but that's what you're doing. So what is -27 and 2? So I'm gonna have to add 2 to both sides. Y equals x minus 5 squared plus 2, which is what we ended up with. Yeah, you're welcome. Okay, let's look at letters E and F. E and F. Okay, E. So notice that all of our examples up to this point, B has been an even number. B has been an even number. So I'm just going to start with the y-intercept, 0, 4, and then I'm going to show my work. So remember that I have to move this constant over first. So I really have y minus 4 equals x squared plus 5x. 5 is my B term, so I have to take 5 divided by 2. And I have to square it. What is 5 divided by 2 squared? Well, 5 times 5 is what? 25. And 2 times 2 is? So this really is x plus 5/2, the quantity squared. And when I do that, I'm adding a secret 25/4 to both sides. That's what I'm adding to both sides. Well, that 4, this whole number -4, that's the same thing as -16 over 4. So what is -16? What is -16 plus +25? -16 plus 25 is 9. So y plus 9 over 4 equals x plus 5/2, the quantity squared. So now I'm going to move that plus 9/4 back to the other side by subtracting it. Oh, I don't know why that did that. So y equals x plus 5 over 2, the quantity squared, minus 9/4. So my vertex, -5 over 2, comma, -9 over 4. The fractions are tough. Okay. So what about this one? So what should I do first? I'm going to add what to both sides? I'm going to add 2 to both sides because I want to cancel out that -2. So y plus 2 equals x squared minus 9x. So what's half of 9? Well, half of 9 is 9/2. So that's what I'm going to write. Y minus 9/2, the quantity squared. But what am I secretly adding to both sides? Well, I have to square that 9/2 to figure out what that is. And I'm secretly adding, let's see, 9 times 9 is 81 over 4. I'm secretly adding 81/4 to both sides. Well, this whole number 2 is the same thing as 8 over 4. 8 over 4 plus 81 over 4 is 89 over 4 equals x minus 9/2, the quantity squared. Last step, you're going to subtract that 89/4 from both sides. So y equals x minus 9/2, the quantity squared, minus 89 over 4. So my vertex is 9/2 and negative 89 over 4. And I think if you put that into a decimal, you would get 4.5 and negative 22.25, right? Is someone mathing that for me? I think that's what that is. Okay. So I'm going to freeze that so you can take a look at it. Your homework today is taking place on page. So you guys are going to do page 35 and number 6 on page 36. That's it. Don't do 7 or 8. We're going to do 7 and 8 together in class, as well as this back page. What happens when A is not 1? What happens when A is not 1? So page 35 is your homework, 1 through 5, and then number 6 on page 36.